Data handling. In your day-to-day life, you might have come across many informations such as runs made by a batsman in the last 10 test matches, number of wickets taken by a bowler in the last 10 ODIs, marks scored by the students of your class in the mathematics unit test, number of storybooks read by each of your friends, etc. The information collected in all such cases is called data. These informations are represented in different types of graphs. What was the first type of graph you came across when you were in primary class? Yes, it was a pictograph. A pictograph is a pictorial representation of data using symbols. This is a pictograph for the sales of a car company for 3 months, July, August and September. It is taken that one symbol of a car represents 100 cars, so half symbol of a car will represent 50 cars. How many cars were produced in the month of July? Yes, 250. In which month were the maximum number of cars produced? You can see that in the month of September, maximum 400 cars were produced. And in the month of August, 300 cars were produced. Bar graph. A bar graph is a display of information using bars of uniform width, their height being proportional to their respective values. See, this is the example of a bar graph of a group of people in which different bars shows the number of people who liked different fruits. You have been given a bar graph and you have to answer a few questions based on it. What is the information given by the graph? The information given is the number of students studying in a school in 5 different years. In which year is the number of students minimum? 2003, 2004. In which year was the number of students maximum? You can see from the graph that the number of students was maximum in the year 2007-2008. State whether true or false. The number of students during 2004-05 is twice that of 2003-04. See, now look at the graph. Number of students in 2003-04 is 100 and 2004-05 is 200. So, the answer is correct. The next type of graph is histogram. Group data can be represented in the form of histogram, where class intervals are taken on the x-axis and frequency on the y-axis. There is no gap between the bars. This is the example of a histogram. You can see that the bars are attached to each other. There is no gap between them. See, these are the examples of a bar graph and a histogram. You can see that there are gaps in between bars of a bar graph, whereas in histograms, the bars are attached to each other. The next type of graph which we are going to see is a double bar graph. A double bar graph is a bar graph showing two sets of data simultaneously. It is useful for the comparison of data. This is a double bar graph representing the marks obtained by a student in different subjects in 2 different years. What is the information given by the double bar graph? The information given by the double bar graph is subjects on the x-axis and marks obtained by the students in two different years on the y-axis. In which subject has the performance improved the most? On looking at the graph, we can say that the student has shown maximum improvement in mathematics. In which subject has the performance deteriorated or decreased? You can see that the performance has decreased in English. In which subject has the performance remained the same? That means the student has shown no change in performance. Yes, in Hindi the student has shown no change in performance. Organizing data. Usually the data is available to us in an unorganized form called raw data. What is frequency? Frequency is the number of times that a particular entry occurs. To draw meaningful inferences, we need to organize the data systematically. Frequency distribution table. The table made is known as frequency distribution table as it gives the number of times an entry occurs. A group of students were asked about their favorite subject. The results are given below. You have to organize this data in the form of a frequency distribution table. We will arrange the data in the table using tally marks. See, we will go on striking one object and putting the tally marks for it. When we finish off the fourth tally mark, the fifth one will be striking the four of them. Now, let us learn how to draw a bar graph. The shoppers who came to a departmental store are marked as man, woman, boy or girl. The following list gives the shoppers who came during the first hour in the morning. The list has been given. You have to make a frequency distribution table using the data and also make a bar graph to illustrate it. We will make a frequency distribution table for the given data with 3 columns: shopper, tally marks and number of shoppers. Shopper are woman, man, boy and girl. On completing the tally marks, we see that number of women is 28, number of men is 15, number of boys is 5 and number of girls is 12. Now we will prepare a bar graph for the given frequency table, taking shoppers on the x-axis and frequency on the y-axis. That means on the y-axis we will take number of shoppers. The scale taken is 1 centimeter is equal to 5 shoppers. Now let us take another example of an ungrouped data where we have to construct the frequency distribution table for the data of weights of 20 students of a class using intervals 30 to 35, 35 to 40 and so on. The data given is 40, 38, 33, 48 and so on. Dear students, in this case, if we go on making graphs for the different weights of the students, we will have many bars on the graph and it will become very confusing. So, we will make a frequency distribution table for the data using the intervals 30 to 35, 35 to 40 and so on. Here also we will make the frequency distribution table, but we will take class intervals as 30 to 35, 35 to 40, 40 to 45 and so on. Now dear students, you can see that 35 is repeated twice, 40 is repeated twice and so on. So where will 35 lie? It will lie where it is in the lower limit. That means in the interval 35 to 40. Where will 45 lie? In the interval 45 to 50. If you have a data as 60, it will lie in the interval 60 to 65. Now let us learn how to draw a histogram. The weekly wages in rupees of 30 workers in a factory are given. Using tally marks, make a frequency table with intervals 800 to 810, 810 to 820, and so on. Also make a histogram for it. Now we will make the frequency distribution table for the given data with class intervals, tally marks, and frequency as 3 columns. Based on this frequency table, we will make a histogram. Since we have been given the class intervals, the bars will be joined to each other and we will get the histogram. The scale taken is 1 centimeter is equal to 1 worker. The next type of graph is circle graph or pie chart. Have you ever come across data represented in circular form as shown below? These are called circle graphs. A circle graph shows the relationship between the whole and a part. The whole is a circle which is divided into sector. The size of each sector is proportional to the activity or information it shows or displays. Let us take the example of this pie chart. It gives the expenditure in percentage on various items and savings of a family during a month. On which items the expenditure was maximum? Look at the graph. The sector of which item is the biggest? Yes, it is for food. So the expenditure is maximum on food. The expenditure on which item is equal to the total savings of the family? Looking at the pie chart, we can see that the expenditure on education of children is the same as the savings of the family. Both are 15%. If the monthly savings of the family is rupees 3000, what is the monthly expenditure on the clothes? Let us consider the total income of the family is equal to X rupees. Savings is 15% of this total income. 15% of X is equal to 3000 rupees, which gives us 15x by 100 is equal to 3000 rupees. X is equal to 3000 into 100 by 15, 20,000 rupees. This 20,000 rupees is the income of the family, and expenditure of clothes is 10% of this income, that is 10% of 20,000 rupees. 10 into 20,000 by 100, 2,000 rupees. Now we will learn how to draw a pie chart. Take this example. The favorite flavors of ice creams for students in a school is given in the table. You have to represent the above data in the form of a pie chart. Now we will make a table to find out the central angle for each part. For this, we will divide the table into 4 columns. The first is flavor, second percentage, third is the fraction for each part, and fourth the central angle. Given chocolate is 50%, vanilla 25%, and others 25%. Now we will find the fraction for each part. The fraction of chocolate will be 50 by 100, that is 1 by 2. The fraction for vanilla will be 25 by 100, that is 1 by 4. And the fraction for others will be 25 by 100, that is 1 by 4. To find the central angle for each part, we will multiply the fraction of each part by 360 degrees. Why is it so? Because a complete angle is always 360 degrees. So, the chocolate will be half into 360, 180 degrees. Vanilla will be 1 by 4 into 360, 90 degrees. And others will be 1 by 4 into 360, 90 degrees. Let us make a pie chart or circle graph for the given data. Let us draw a circle graph or a pie chart for the given data. First, we will draw a circle of any radius. We will draw any radius. We will mark any radius. Then, we will keep the protractor on this radius and mark angle 90 degrees. With the help of a ruler, we will make angle 90 degree. The line will touch the circumference of the circle. This will give you sector for vanilla. Next, you will keep the protractor on the new radius and again draw an angle of 90 degree. This will give you sector for others. The third sector will be the sector for chocolate. You can make your pie chart or pie graph colorful by shading the different sectors in different colors and naming it different ways.